Nakoto. Hello, everyone. My name is Priscilla Bezin, and today I'll be presenting this paper written by myself and Dr. Paula Buarin. We are both from the School of Architecture and Planning at the University of Auckland here in New Zealand, and we are part of the Future Cities Research Hub. The title of the paper is Energy Retrofit of Historic Buildings in Aotearoa, New Zealand, Current Practice, Challenges and Opportunities. And this was part of my PhD research at the University of Auckland. With the challenge of climate change, energy retrofits is starting to be recognized as a protection tool for built heritage internationally. Heritage-compatible energy retrofit can help improve thermal comfort and reduce energy consumption in historic buildings, reducing operational carbon emissions and operational costs as well. In New Zealand, however, development in this field is still very limited. Current policies in New Zealand focus on another challenge of seismic strengthening our historic heritage due to the many earthquakes in the country. So there is limited literature on the current practices, challenges, and barriers for energy retrofit in Aotearoa. So the objectives of the study were to investigate in the New Zealand context the state-of-the-art of historic building energy retrofit practice, the balance between different disciplines involved in these projects, the main barriers to the uptake of energy retrofit, the impact of heritage policies and approvals, and unique aspects in retrofit in New Zealand, including the integration of energy and seismic retrofit, and also opportunities for encouraging energy retrofit. So to fill this gap in knowledge, our methodology included a questionnaire with professionals involved with retrofit projects in New Zealand, and we sent 1,906 email invitations to professionals that were selected from publicly available databases from their professional institutes. 234 responses were obtained from this, and this resulted in a response rate of 12.3%. And then after the questionnaire, we followed up with semi-structured interviews, and these were carried out with 6 professionals that were selected to represent all the different disciplines involved in the questionnaire. And the figure on the right shows the occupation range of questionnaire respondents with a prevalence of architects followed by engineers and other consultants, including heritage consultants and quantity surveyors, project managers, and builders. So the results from the questionnaire and interviews were organized into 5 main topics. The first one was on general views about retrofit and balance between different disciplines involved in these projects. So in general, participants agree that historic buildings should be upgraded to new requirements and technologies in a sensible way that maintains their character. So there was a general support to the idea of heritage-compatible energy retrofit of historic buildings. In general, participants agreed with the ideas that historic buildings can become more energy efficient with appropriate retrofit measures, that energy efficient buildings are important for a sustainable future, that historic buildings are important for our future generations, and that historic buildings are more likely to be retained if they serve a useful purpose. So in general, participants were very supportive of the idea of retrofitting our historic building stock and adapting our buildings for now and for the future. This support to sensitive energy retrofit was then confirmed in the interviews, and here's an example from a senior conservation architect from Heritage New Zealand saying that our historic buildings need to be adapted to be comfortable environments, to be energy efficient environments, because otherwise they end up being abandoned and unused. When asked about the balance between different disciplines in retrofit projects, the level of importance to different disciplines was generally following the policies that are in place in New Zealand. So weather tightness, structural safety, including seismic strengthening and fire safety, which are all mandatory, aspects were the first in this ranking, and then thermal comfort and energy efficiency, for example, were lower in the ranking. It's also interesting to note here that aesthetic and cosmetic upgrades, such as updating thermal internal finishes, were the lowest ranked at all, were not considered very important by the professionals. Looking at current retrofit practice and the most common types of interventions being undertaken in New Zealand, seismic strengthening is again at the top of the list. So it aligns with the current policies that are in place in New Zealand. And then secondly, we have updating kitchens and bathrooms, which contrasts with the previous table where it was not considered a high priority by practitioners. But of course, it is highly valued by the property market in New Zealand. Then highlighted in red, we have the main energy retrofit interventions being undertaken. So insulation to ceilings or roofs is the most common type of energy retrofit upgrade in New Zealand. And the second one is upgrading to LED lighting. So both of these are usually the least invasive interventions and also usually lower cost. This is followed by wall insulation, floor insulation, and then HVAC system upgrades. And lastly, we have the upgrades to windows, which was not found to be very common in historic buildings, and upgrades to air tightness and renewable energies additions such as PV panels. One question asked specifically about window upgrades in New Zealand, and it reviewed that secondary glazing, although being the preferred option by Heritage New Zealand according to their guidance documents, is actually the least common type of window upgrade. And the complete replacement of historic windows was found to be the most common type of window upgrade in the country, which is a very invasive type of intervention. And we looked at barriers to energy retrofit in New Zealand, and as expected, the main perceived barriers were related to costs. First of all, cost of materials, and secondly, cost of labor. This was followed by lack of interest from clients, difficulties in obtaining approval from heritage authorities, approvals from council, and then also lack of knowledge from the design team and the construction team. There were also other reasons mentioned by participants. Some of these barriers were then questioned in the interviews. Many professionals said that actually cost of materials is not the main challenge, but the cost of labor is the real problem in retrofit projects and is the main barrier to energy retrofit interventions. Lastly, we analyzed opportunities for improvement and the possible integration between energy and seismic retrofit in New Zealand, and particularly about the integration between energy and seismic retrofit. There was strong support that this should be done whenever possible. When a major upgrade is planned, upgrading all services should be considered. Other comments saying that it is practically feasible, but there were comments about the economical feasibility that relies on more value being placed on energy performance across all sectors. And there were a few, less than 10% of respondents saying that seismic strengthening is already challenging for owners, so suggesting additional upgrades may be overwhelming and cause owners to find ways to demolish buildings. But in general, there was strong support to this idea and many examples where this has already been done. In limited circumstances. So this was actually the direction that the research took after the questionnaire, and this is where my PhD research has focused later on the integration of energy and seismic retrofit in New Zealand. So the main conclusions from the study are that there's general support and interest in energy retrofitting historic buildings, but a lack of application in current projects in New Zealand. The most common energy retrofit measures implemented were roof insulation and upgrade to LED lights due to their low cost and relatively low impact on historic fabric. The main barriers to the uptake of energy retrofit are related to costs, also about uncertainty about obtaining approval from councils and heritage authorities, lack of knowledge in the industry, and lack of interest from clients. The main opportunities for encouraging energy retrofits are to encourage better education and examples of completed projects, integrations of energy retrofit to seismic strengthening, availability of more public funding, and public-private partnerships for the retrofit of heritage-listed buildings. Thank you for watching this presentation, and we would like to thank all the professionals who participated in our questionnaires and interviews for this study. Thank you.